We are producing a lot more data than we're capable of storing today. We think that to put a dent on the problem, we need a radical new solution. And so we're looking at DNA as one such solution.
And one of the reasons that we're using DNA is its density is orders of magnitude higher than anything that exists today. Its reliability and resiliency, and then it has relevancy. We think that as long as there are humans alive, we'll care about reading our own DNA. And that means that we'll have a storage format that will be with us that will always be relevant.
We have been working on using DNA for data storage for several years now, but the process so far has been incredibly manual. There are literally people moving around with pipettes in their hands. So the only way we're going to make DNA data storage scale up to be usable and be, go mainstream is by automating it. And what we've done with the project that you're going to learn more about now is showing that it's possible to automate the entire process from bits to molecules and back to bits.
The writing process takes your data file and encodes those ones and zeros into ACs, Ts, and Gs. Those ACs, Ts, and Gs are actually what gets sent to the device itself. Every base that flows into the column incorporates itself onto a strand of DNA. So once all the DNA bases have been incorporated into the strands on the column, the strands need to be removed from the column. So we pump a chemical mixture into the column which frees them from their solid support and pushes them into a liquid storage bottle. So once we decide to read the data off the DNA, the read master mix is applied to the DNA storage pool. That master mix prepares the DNA to be read. Now that the DNA is readable, it gets pumped into the read device where it gets translated into ACs, Ts, and Gs sequences that the computer can understand. Those sequences then get decoded back into ones and zeros. Moving into the future, what we'd like to do is move fluids around in a more intelligent way, which is accomplished by the Purple Drop project.
So we're basically making the biological primitives, moving and mixing droplets, accessible like software is today, because you can just compose it as much as you want. So you can start with simple systems, and then you can build it up into like an automatic experimentation machine.
Basically what you're doing is, because water is polarizable, you can generate a charge in it. And so by changing the charge on the board in different locations, you can attract the water to those locations.
And I think the other thing that's interesting to realize about this result too is that this might be pointing to a new kind of computer system that has an electronic component and a molecular component. So you use molecules for what they're good at, use electronics for what they're good at, and then you integrate them and show that it's actually possible to build a system that has dry electronics, wet molecules, and they together do something amazing.
Microsoft has seen this impending crisis of not being able to store information as we move forward and invest in a technology that could revolutionize the way that we think about data storage.